through and review our tissues, and then we're going to start talking about skin. Okay? First tissue. What type of tissue is this? Stratified squamous epithelium. What is its function? Protection. Where is it found? Anywhere where there's abrasion. So skin. Anywhere else? Mouth. Vagina. Good. Okay? Very good. What type of tissue is this? Simple columnar epithelium. Some of you didn't answer very quickly. How do I know this is epithelium? It's got a basement membrane, open at the top, good. All the cells are touching each other, okay? What is the function of simple columnar epithelium? Absorption and secretion, good. If it is a mucus secreting cell in the digestive system, what's it called? Goblet cell, good. Good. That was just a little small aside to see if anybody knew that. Good. All right. I told you the answer, but where is this commonly found? Digestive system. What is this? Dense, regular connective tissue. What's its function? Okay. It does stretch some, but what type of fibers are those pink fibers? Collagen. Is collagen known for stretchy? It's known for strength, right? This is found in tendons and ligaments. And why do we have tendons and ligaments? So they can provide some strength and some resistance, right? If I grab each side of this tissue and pull, it's not just going to stretch and pop right back because it's full of collagen fibers. It's just going to be strong and allow me to pull on it. It's the same one y'all missed last week, okay? Dense, regular connective tissue. What is this? Adipose tissue, which is the fancy word for fat. Okay? Where is this found? Eyeballs, kidneys, under the skin, pretty much everywhere in your body. If you have epithelial tissue, there's usually some fat underneath it. All right, what is this big white glob right here representing? That's the fat. Okay, I heard some people say adipocytes, so I'm going over it. Adipocytes are actually these little smushed together things here. The big white bubbles are where the fat is filling up the adipocyte and pushing the nucleus and everything to the side. What's the function of adipose tissue? Insulation, protection, and cushion. Good, I heard all three answers. Okay. What is this? Good, elastic. Cartilage. How does she know elastic right away? The little black squiggly fibers are elastic. How did you know cartilage? Eyeballs. What are the eyeballs actually called? Chondrocytes sitting in lacunae. Very good. The chondrocytes are the cells. The lacunae is the little house that it's sitting in. Okay, very good. Where is elastic cartilage found? Your ear. And also your epiglottis, that little flap that controls food and air movement. We'll learn about that in A&P too. What is this? Bone. Osseous tissue, good. That's the fancy word for bone. Okay, osseous means bone. All right, how do we know this is bone? Spiderwebs, tree chunks, however you remember it. Good. Where do we find bone tissue at? In the bone, good. What's the function of this? Support, protection. Okay. It also could technically be storage because our bones do store some things, but good. All right. What type of cells will we see in here? Osteocytes, osteoblasts. Good. What's the difference between a blast and a cyte? Maturity. The blasts are the immature. The cytes are the mature. Very good. So this is a connective tissue. Why don't I ask this question? What do all connective tissues have? Name the three components of all connective tissues. Ground substance, fibers, and cells. Very good. What are the three types of fibers? Elastic, collagen, and reticular. Very good. What is this? Simple squamous epithelium. What's its function? Allow passage, diffusion, movement of molecules, any of those works. Where do you find this type of tissue at? Air sacs of the lungs. Good. What's this? Good. Ciliated, pseudostratified, columnar epithelium. What is its function? Secretion of mucus. Secretion and what of mucus? Movement. What are the little cilia for, right? Once it secretes that mucus, the little cilia kind of wiggle and move the mucus along the way. Good. Where is this commonly found? Respiratory tract. Good. What is this? Reticular tissue. Good. Most people always say reticular and they're trying to think, wait, what's the rest of it? Because it seems like it needs something else. It's just called reticular tissue, reticular connective tissue. Where is it found? Lymphatic tissues, immune system organs. Okay. That's all we're going to do with that. What's this? Good. Fibrocartilage. Okay. Remember, even though they're smaller, these are the little eyeballs. These are little chondrocytes with the lacunae. Where is fibrocartilage found at? Knees, vertebrae, holding the two hip bones together, called the pubic symphysis. So what's its function? Absorb shock. Very, very strong tissue. Excuse me. All right, what's this? Blood. Where's it found? Blood vessels. Good. And what's its function? Transporting things to the body. Good. What's this? Skeletal muscle. Good. Is it voluntary or involuntary? Voluntary. Good. Where's skeletal muscle found? Attached to your bones. Good. What's this? Simple cuboidal epithelium. Good. I heard a few weird answers, but simple cuboidal epithelium. What's its function? Filtering, secretes and absorbs certain things. Selective secretion and absorption is probably the technical term for it. Where do we see this at? What organ mainly? Kidneys. Also some in the ovaries and things like that. Good. What's this? Cardiac muscle. What's this? Oh, I want y'all to say it. I like hearing you say it. What is this? Oh, you said it right. Intercalated disc. It's always really funny to hear you guys say. It's called an intercalated disc. Good. Voluntary or involuntary muscle? Involuntary, found in the heart. What is this? Nervous tissue. Good. I heard neurons. What's that word mean? That's the actual cells. Good. Where do we find nervous tissue at? Brain, spinal cord, and nerves. What's the function of nervous tissue? Transmitting signals. Okay, it's actually electrical signals, but good. What's this? Smooth muscle, very good. Voluntary or involuntary? Involuntary. Where's smooth muscle found? Lining of your internal organs. Okay. What's this? I missed this one last time. Come on. Good. Areolar, also just called loose connective tissue. I need to sit by her next week. She knows her stuff, right? This is areolar connective tissue. Where is it found? Found under the epidermis of the skin. It's the second layer of your skin. What's it for? Provide some cushion, some resistance for your skin. Okay. What are the pink things? Good. What are the black things? Good. What are these cells called? This isn't cartilage. Fibroblast. Good. All right, what's this? Okay. Dense, irregular, connective tissue. And what's its function? It can stretch in all directions to provide some resistance of stretch in all directions. Good. Where is it found? It's found under the skin. It's the next layer of skin. What's this? Hyaline cartilage. Well, I lost everybody. For a while, everybody was answering. Now we're in the same thing. People. Hyaline cartilage, where is it found? In the bones. All your bones have a piece of hyaline cartilage on them. Okay. What's this? Transitional. What type? Epithelium. What's its function? Stretching for storage. Good. And where's it found? Only in the bladder. Very good. Okay, we're going to do this today. So how many of you are starting to feel pretty good about that? Y'all really all did good. It kind of like decreased as we went through. So if y'all learn them in order, I guess that makes me feel good. It means y'all really studied and you really got the beginning and need a little more studying in the end. Okay? You need to be able to do what we just did as a class. Okay, somebody asked me to, so I uploaded that PowerPoint of just the pictures. And that's a good way to study. Just turn your computer on, pull up that PowerPoint, and look at the pictures. Identify it, and then ask yourself, what's its function? Where is it found? Okay, if it's got some big thing in it, see if you can name what that big part is or something like that. Okay? All right, we are now ready to discuss the integumentary system. Okay? But we're actually not going to do all of it. We're just mainly going to focus on the skin. A system is a collection of organs that work together to perform some sort of function. An organ is a collection of more than one type of tissue that works together. Okay, did everybody understand what I just said? We're going to focus on the skin. That's an organ. So obviously that piece of skin is going to be a combination of more than one type of tissue. Your skin is going to have a couple different areas. It's going to have epithelial tissue and connective tissue in very specific places that make up your skin. The other organs of the integumentary system are your fingernails, your hair, certain pieces of your glands. And we're just not going to go into a whole lot of detail with all of those just for time purposes. Okay, but we're going to do a good bit with the skin. Okay, so let's look at our skin. Your skin, a lot of times you'll see the question, what is the largest organ in the human body? It's kind of a trick question. You know what the answer is? Your skin is your largest organ. Because most people don't tend to think of the skin as an organ. But it is. Your skin has three regions. The epidermis, the dermis, and the hypodermis. The epidermis, the most superficial region of your skin, is made of epithelial tissue. Okay. Can anybody guess what type of epithelial tissue? Stratified squamous, right? We've already kind of learned that. Okay. The middle part, your dermis, is made of connective tissue. Okay. It's actually made up of more than one type. The first type is areolar connective tissue. Then below that is dense, irregular connective tissue. The hypodermis is also connective tissue, but it is mostly adipose tissue. Okay? And have you ever heard that women have more fat than men, no matter what we do? That is true. Okay? And this is where women typically have more fat than men. Women have a thicker layer of adipose tissue underneath their skin, and that is simply because women's bodies are scientifically supposed to be used as incubators at some point in their life for a baby. So that's why we have to have more insulation on the outside of our body. Okay? All right. So now we're going to look at each part of that a little bit closer. This picture you are going to see again. Okay? I'm not sure if it's on your lecture test. Can't remember if I put it there or not. Made it last week. But this picture is definitely going to be on your lab practical. Okay, I know some of you don't have lab, but bear with me for just a second. Also in lab today, we have several models of the skin. So it makes it more three-dimensional, and you're going to look at something like this in lab. That's what we're going to add today to what we've been doing in lab. Okay? Now when we look at this, you should clearly be able to see where the type of tissue changes. So this part up here at the top, that's the epidermis. Down here is the dermis. And then just starting at the bottom where you see the big globs of fat, that's what would be considered the hypodermis. And the hypodermis continues until you start getting into serous membranes, which your organs are going to be connected to those. Okay, your internal organs. Okay. Now, we're not going to spend really much time talking about other things like hair and fingernails, but just from looking at this picture, do you see how the epidermis kind of dips down, wraps around the piece of hair, and then comes back up? Your hair and your fingernails and your toenails are actually part of your epidermis that just dip down into the dermis. What is in your dermis are things like blood vessels, nerves. Okay, you have some little muscles that tell your hair when to stand up, when to lay down. Okay, so when you get chill bumps or goosebumps, that's those little muscles underneath in your dermis make your hair stand up. Okay, these little things are a special type of sensory nerve called a Pacinian corpuscle. Okay, attached to each hair follicle is a special gland called a sebaceous gland. Does anybody know what it makes? Oil. So it makes sebum, which is oil. Okay, oil on your skin and hair, is that a good thing or a bad thing? A very good thing. If you wash your hair too much, or if you take a bath too many times a day, you wash the oil off of your skin and your hair. That's very good for your body for lots of different reasons. Okay, I preach it, but I'm guilty of it. All right. Also have sweat glands. We have two types of sweat glands we're going to learn about. This picture only shows you the eccrine sweat gland, but we're also going to talk about apocrine sweat glands. Some of your sweat glands are stinky. Where do you think those are? Armpits and your anogenital regions. That's the stinky part. The other parts of your body have these eccrine sweat glands. They just release water. Their job is to cool off the body. Okay? When you first start sweating, like 8 o'clock this morning, it was very warm in this building. Okay? We all had little beads of sweat on our forehead. That's the little eccrine sweat glands trying to cool off your head. It's an important appendage to your body, so we got to keep it cool. Okay? So we're going to go through and we're going to talk about each of these parts, but I tell you that you need to come back and make sure you can label this picture after we're finished talking about each individual thing, okay? All right, so we're going to start with the epidermis. Your epidermis is composed of keratinized stratified squamous epithelium. Now, we all know what stratified squamous epithelium is, right? Okay. We need to learn what keratinized means. Okay? To do that, we need to look at the 4 types of cells found in your epidermis. In your epidermis, you have keratinocytes. Keratinocytes produce a protein called keratin. Keratin is a waterproofer. Okay? So why do we put waterproofing on like outdoor decking and stuff like that? Keep it from rotting. Okay? We don't want water to go into it. So why do you think we need to keep our skin keratinized? It's not so it won't rot, but do we want to let water into it? No. Do we want to let things out? We want to keep certain amounts of water in our skin, but we don't want too much going in there. Otherwise, when we went swimming, we would all swell up and fill up with water, right? We don't want that. But at the same time, we don't want to be standing here and all the water just drain out of our skin. So we put that waterproofing, that keratin layer in our skin. Okay? The second type of cell is called a melanocyte. They produce a pigment called melanin. Okay? Melanin is one of the main determinants of our skin color. Okay? Does anybody know why we make the pigment melanin? To protect the DNA in our skin. Very good. Okay? The way it actually works, it makes us pretty too, right? We all like it when we have a nice dark color to our skin. Okay? So what actually will happen, here's the normal cells in your skin. Okay? So I'm just going to draw some circles. Those are the cells in your epidermis. Okay? Well, the melanocytes will produce the pigment melanin, and then all the other cells, including the melanocytes, will grab that pigment and collect it and put it on the outside of their cell. Well, inside of this cell is a nucleus with DNA in it. So by having that dark pigment on the outside of the cell, when the sun hits the cell, it can't get to the DNA to damage the cell that's on the inside of your skin. Okay? So what happens to us? The more we stay out in the sun, what does our skin do? It gets darker and darker. Because if we're in the sun, we're telling our body, this person's going to constantly be around sunlight. You need to make more and more melanin to protect the DNA because she's always going to be out in the sunlight. Okay? So that's why we produce it. Then it's a very simplistic version, but okay? All right. We have something called Langerhans cells and then something called Merkel cells. Again, these are things that people like to name after themselves. The Langerhans cells are just special types of dendritic cells that are part of our immune system. You don't have to understand all the details, but you know, what does your immune system do? Protects you from what? Infection, disease, causing agents coming into your body. So if a nasty bacteria gets on your arm and starts making its way through, you have these nice little immune system cells that will grab that bacteria and destroy it before it can get to your blood. Okay? The Merkel cells are a special type of what we call tactile cells, a touch receptor. If you push on them, they lean and activate a nerve that's next to them, sending an impulse to the brain, telling your brain that something's touching your arm right there. Okay? We're not going to do too much with those, but you do need to understand really specifically the purpose of the keratinocytes and the melanocytes. Keratinocytes produce keratin, that waterproofs our skin. Melanocytes produce melanin. The melanin protects the DNA in our skin cells. Got it? Okay. If we talk about the epidermis, we break it down into 5 different layers. Okay? And the notes are set up describing the layers from deep to superficial. Now that I look back on it, that probably wasn't the best way to do it. Probably should have started outside and went in. But I decided to go to the deepest layer of the epidermis, and we're going to go up. And then we'll go below that. Okay? So if we start with the deepest layer of the epidermis, that is called the stratum basal, the basal layer. Basal means bottom. Okay? The reason I originally started with this layer is because this is one of the most important layers of your skin as a whole. This is the only layer of your skin that is highly regenerative. Okay? So whenever you start making new skin, that means the deepest layer of your epidermis, the stratum basal layer, it is undergoing rapid mitotic division. Okay? Have any of you ever been sunburnt and peeled? Okay? Some of us probably way more than we probably should have. Okay? Well, as you start peeling, you don't peel off and have like a bloody connective tissue layer underneath, right? That's because as you damage the top parts of your skin is regenerating from the inside and starts growing out. So when you get a nice new pretty layer of skin, that old skin that you damaged is okay to dry up and completely flake off. But we do that every day. If you put your arm in the sunlight and do like this, you'll see little cells float off. That's okay though, because you've got your basal layer constantly producing new cells. So let's say I go lay out on the beach and get a nice pretty tan, and I don't get sunburned. I do it the smart way, but I still got a pretty tan. Is that tan going to last forever? How long does that tan last? It depends on who you are, your natural skin color, things like that. But on average, about a month, you'll still be able to see tan lines. Okay? That's because it takes somewhere around 30 days on average for the cells that are made at your basal layer to make it to the outside. So if I get tan today, it doesn't matter. 30 days from now, the cells that were all the way down, way at the bottom of my epidermis, are going to be on the outside of my epidermis, and they didn't get tan. So that's why I have to keep tanning over. Some of you are looking at me like, I don't tan. Stop talking about it. Sorry, I like to tan. Okay? But if you guys will remind me when we're done with all of this, we're going to talk a little bit about skin cancer because I had it. So I have some pretty interesting little things to tell you. So that's why I stand up here and talk about tanning, and then I can show you my skin cancer scar. So, all right. So moving up from the basal layer, and more superficial, the next layer we have is called the prickly layer, properly called the stratum spinosum. Okay? The stratum spinosum is called prickly because if you look at the cells under a high-power microscope, the cells kind of have like a, instead of being perfectly shaped, they kind of look like they have little spines sticking out of them. Okay? And those little spines are actually desmosomes, which are fancy linkages between cells, where one piece of one cell will kind of stick out and the fibers will grab a hold of each other and make the cells lock really, really tight together. The other reason they're prickly is because this is when we start to make huge accumulations of melanin and we begin making our keratin. So you just have a whole lot of fibers in these cells, so they can't be perfectly round anymore. Okay? Above the prickly layer is the stratum granulosum, the granular layer. Okay? And what do you think it looks like under a high-power microscope? Grainy. That's why we call it that. Okay. This is where we now have tons of a precursor to the final keratin in our cells. So there's so many little pieces of solid fiber in the cells that when you look at it under the microscope, you can see the little dots of fibers, and that's why we call it the grainy layer. Okay. Going up from the granulosum, I'm going to skip this and come back. The topmost layer is called the stratum corneum, also called the horny layer. Okay? And that's simply because the cells look like they have horns. The horns are where the cells are actually beginning to have pieces break off. That's the outside of your skin. Okay? Your skin feels smooth when you feel of it. But we've already looked at some skin in the microscope. When you look at it in the microscope, there's never a flat line at the top of the skin because there's always pieces of that stratum corneum flaking off. The stratum corneum cells are 100% dead, 100% filled with keratin, and that is what gives us, that's the thickest part of our skin, gives us the characteristics of our skin we think of when we think of skin. Completely able to waterproof, okay, protects us from just about anything that we are going to do to ourselves throughout the day. Okay? Keratin. Keratin. Okay? Now I skipped a layer. Okay? I skipped a layer for a reason. Because there's actually two types of skin in our body. And the presence or absence of the layer I skipped is what determines which category we put our skin in. Our skin is either considered thick skin or thin skin. What do you think the difference is? One's thicker than the other, right? So which one do you think has the extra layer, the thick skin or the thin skin? The thick skin, all right? Thick skin is found in only two places on your body. The palms of your hands and the soles of your feet. What is different about the palms of your hands and the soles of your feet than everywhere else on your body? It doesn't have hair and thicker. It's tougher. It's not as sensitive, right? Okay. If you touch this side of your arm to something hot, compare that to touching your hand to something hot. Okay. It hurts a lot more when you touch anywhere else than that thick skin. Okay. Well, why do you think we have it there? Why do we have more resistant, tougher, thicker skin on our hands and feet? Because we use our hands and our feet to walk, and that's our first touch for things. Okay. So just evolutionarily, it made sense for us to have thicker skin there. So on those two regions, palms of the hand and soles of the feet, we have the extra layer between the granulosum and the corneum that's called the stratum lucidum. It's called lucidum because it's clear. Okay? It's just a dead single row of cells. In lab today, we're going to look at a bunch of different slides under the microscope, and I'm going to show you how to tell whether they're thick or thin. Okay? All right, we got our 5 layers. Okay, starting at the bottom, stratum basal, right? Okay, what's special about the basal layer? Highly regenerative. After the stratum basal, we have the stratum spinosum, spiny layer, then the stratum granulosum. Then if it's thick skin, we have the stratum lucidum. Then top is the stratum corneum. So go ahead and learn them in order. I'm going to ask you questions. You know, if you stuck a needle in your arm, which of the following is the correct order that needle's going to go through? So you need to know, stuck a needle in my arm, what's the order it's going to go through? Corneum. I said in my arm. So is there going to be a lucidum? All right, got tricked you. All right, corneum, then granulosum, spinosum, basal. Okay? Be able to do it back and forth. Okay? So is everybody comfortable with the epidermis? Now we're going to look at the dermis. Again, the dermis is made of connective tissue. The dermis is made of mainly 2 types of connective tissue. So we actually break the dermis into 2 parts instead of 5 like the epidermis. Okay? The 2 parts of the dermis are the papillary layer and the reticular layer. Papillary layer is the most superficial, reticular is underneath. Okay? So the papillary layer is areolar connective tissue. Okay? Now, don't flip, just want to show you something. If I go back and look at that main picture of the skin again, okay, see how when the papillary layer of the dermis comes up. See how it has these little ridges? Everybody see that? Those are called the dermal papillae. Okay? The dermis actually sticks up into the epidermis. And it does that in a very specific pattern. Each person's pattern is special to that person. Can anybody predict what those dermal papillae create? Your fingerprints. Okay? You actually have fingerprints over, they're not called fingerprints, but you have a print that is specific to you all over your entire body because those dermal papillae are sticking up. Those are actually made when the baby's in the womb at about 3 months of age. Okay? So you've had your fingerprints for a very, very long time. All right? Now since that layer is made of areolar connective tissue, what does that tell us about that layer of our skin? It's got a little elasticity, right? Areolar had collagen and elastic fibers, right? So it's got a little strength, a little elasticity to it. That's why we can push and pull on our skin, and it doesn't just break and rip and tear. Good. Does it have blood vessels in it? Does connective tissue have blood vessels? Yeah, all connective tissue other than cartilage has blood vessels. Does connective tissue have nerves in it? Yes. Okay? So you can actually start to feel really well, and you can bleed if you get down into this layer. Okay? Now that's only about 15–20% of your dermis. It's a very thin layer. The majority of your dermis forms the reticular layer, and that is made of dense, I don't know why it's not written on here, irregular connective tissue. Okay. So since it's dense, irregular connective tissue, what does that tell us about this layer? What's the main fiber in dense, irregular connective tissue? Oh, the cells are going to be fibroblasts. It's going to be collagen. This is going to give us some strength, all right? It gives us most of our strength to our dermis, actually our entire skin, okay? Now, it does have some stretch and recoil ability, okay? But are there a lot of elastic fibers in dense, irregular connective tissue? Think back to the picture. It's mainly pink, right? Okay? So guess what happens if we stretch this and stretch it and stretch it and pull it? Can it always go back together? If you are too mean to it and you stretch it too far, you get a stretch mark. Right? So when you get a stretch mark, that means you have stretched your epidermis, stretched the papillary layer of your dermis, and you've stretched all the way down into the reticular layer of your dermis. And once that happens, is there any repair in that? Well, you can surgically have it repaired, but there's no cream or anything magical that you can rub on that stretch mark and make it go away. Okay? Save your money. When I was pregnant, I can remember I'd rub that on my belly every night. You know, rub my cocoa butter stuff on my belly every night. Even though I stand here and teach that has absolutely nothing to do with it. You are more likely to get stretch marks if you let your skin get dry. Okay? But other than that, formation of stretch marks is mainly genetic. Okay? So those of you that have not had children yet, if you're worried about getting stretch marks while you're pregnant, it doesn't really have much to do with how much weight you gain or anything like that. Just go look at your mom. If her stomach looks just like it did the day before she ever got pregnant, you're probably safe. If your mom's got a whole bunch of stretch marks, it's probably going to happen to you too. Okay? Now, most of us have stretch marks, and it's not from childbirth. What do most of us have stretch marks from? Well, gaining weight is possible, but even somebody's been skinny their whole life, what have they got stretch marks from? Working out. Look at you. Did any of you grow really fast when you were a kid? Yeah? Okay. I know I have to tell you guys too much about myself, but I've always had stretch marks that run this direction on my hips. Why is that? Because I had a growth spurt like a guy, right? One summer I was a little bitty short thing, and then the next semester we went to school, I had grown 3 or 4 inches. Okay, well, those bones were ready to go 3 and 4 inches. They initiated that growth. Do you think your skin was ready for that? No, so that skin just gets stretched, right? And you may not see stretch marks on the children. The stretch marks won't show up till the skin has had time to try to catch up with the growth. Then you'll start to see stretch marks when they get about to be a teenager. All of a sudden you'll see stretch marks. That can be on really, really thin people. Okay? But somebody else said the other answer, people that have been very, very large and lost weight are going to have stretch marks. And there's nothing you can do about that except surgical removal of them. Okay? All right? Now, we talked about the fingerprints and stretch marks. There's one other thing that I want to mention really quickly right here. Your papillary layer doesn't always, it's not only responsible for things like stretch marks. There are other things. All of your fibers in your papillary layer run a certain direction. Okay, and this is not something I'd ever test you on, but it's just kind of neat. Okay, that means there's certain directions your skin tends to pull in your body. So why does that matter? These create what we call friction ridges and cleavage lines. Okay, so if I just take a knife and cut my arm, is that going to leave a scar? Yeah. But if I go to a surgeon and I have a surgical procedure and he cuts my arm, will I have as bad of a scar? No. That's because a doctor, a surgeon, especially a plastic surgeon, they know exactly where the cleavage lines are. They know the natural way those fibers in the papillary layer like to pull. So they're going to cut along those lines so it'll naturally heal back together and not form a scar. Okay? What's the old way they used to do a C-section? Straight up and down. That's the easiest way to get to the baby, quickest way to get to the baby. Well, you can. You can have multiple C-sections that direction. But that's kind of an old wives' tale. You can get multiple. Main reason you don't do it anymore is because it leaves an ugly scar. Because that's not the way the stomach naturally cleaves. The stomach naturally cleaves this direction. So now a C-section scar runs this way. Okay? Now, if you've ever seen somebody with one, how big does the scar look? Well, the newest, if you have a good doctor and newest ones, that scar is only going to be about that wide. Does that mean that's all they cut? They cut. If you ever watched this happen, they cut a pretty good cut. They dig your intestines out, move them over to the side, and get to what they got to do. So why is there just a little bitty scar? Because they cut right where they were supposed to, and it heals back and you barely see a scar anymore. Okay, so again, that's just for your own information. I always thought it was kind of neat. Okay, the thing there's a picture in your textbook that shows you the cleavage lines, and they don't always run the way you would think. So if you ever had to have surgery or anything like that, compare your scar to the direction of those cleavage lines, and if you have a big scar and it's opposite the cleavage line, you can be mad at your doctor. Okay, he did it and he left it ugly. All right. The next topic we have to discuss is skin color. Okay, and we already discussed this a little bit. What is the main pigment that gives us skin color? Melanin. Okay, what color is melanin? It's actually almost black. It's a very, very dark, brownish black color. Okay, are people only white and brown? Or is that the only two colors people are? No, there's a lot of in-betweens, right? Okay. Well, some of it comes from the amount of melanin, okay? But there's also other pigments in our skin that determine our skin color, okay? And that's how you get, a lot of your more Asian cultures are going to have more of your other pigments than your American is going to have. So most of your color for melanin, the more yellow-orange comes from a pigment called keratin. Okay, and that's just genetic as to how much keratin you're going to have. Now, so what makes you darker in color? What do you think? More melanin, less melanin? More melanin. So are your melanocytes more active if you have more melanin? Do you have more melanocytes? What do you think? Most people think the darker you are, the more melanocytes you have, the more melanin you produce. That's actually not true. We all have the ability, meaning we all have the same, more or less, amount of melanocytes, okay? But the difference is, genetically, my melanocytes may not function quite as much as your melanocytes. So it's going to give you a darker color than me, okay? So why does this work this way? Why would some cultures have more melanin than others? There's got to be a reason, right? Exposure to more sun. What are your darkest cultures? At the equator, right? Why? More sunlight comes in at the equator. So it's in that, so wait, but I've lived in America my whole life, right? Yes, but your ancestors were from somewhere close to the equator, right? So they were always exposed to sunlight. So in their DNA, it codes for melanocytes that are going to be more active, produce more melanin to protect them. And that's something that over hundreds of thousands of years, if you don't live near the equator anymore, you will get lighter and lighter and lighter, right? What do people from like Switzerland and places like that look like? Well, they make me look like I got a year-round tan, right? They are white because they live farthest away from the equator, so they have the least amount of exposure to sunlight. So they don't need as much color in their skin. Okay. Now, me and Jana Causey, we were in grad school together. We've been friends for a long time, and we have decided that we're going to do this one day. When we get enough money, we're going to do the research. Can any of you predict how do you make a permanent tan? All you need is an injection that activates somebody's melanocytes, right? So how many of you that like to tan would go for that? Go get a shot and then beautiful tan, right? No cancer, nothing like that. So see, we're gonna make millions one day. Y'all are gonna see me on the cover of, I don't even know the magazines that show people with money, Fortune or something like that. Okay. All right, what'd you say? Forbes. Yes, I'll be on the cover of Forbes one day when I invent that. Okay. All right. Now that's not the only two things that can give skin color. Your hemoglobin can also give you skin color. Okay. It gives you kind of a pinkish purple, some people would say bluish hue to the skin. Who do you normally see this in? Old people or young people? Old people. Is it because they have more blood? It's because their epidermis is thinner. So you can actually see their blood flowing underneath. And I don't say that to be ugly, but you know what I'm talking about. You've been around your grandparents or something, they kind of have that little bit of a bluish color to their skin. It's because their epidermis is thinner, so you can see the blood flowing under their skin a little more easily. Okay? All right. So what do you think a freckle or a mole is? It's just a place where the melanocytes got a little carried away, and you got a big chunk of melanin in there. Okay, the more you're out in the sun, do you get more freckles? Yeah. Do any of you have the giant freckles on your shoulders? So you're smiling. Okay, that means you've been out in the sun a little too much. Okay, if two freckles stay closer and closer together, you end up with a giant freckle. Okay, when a mole raises, does that automatically mean it's cancerous? It just means the melanin is pushing underneath. When do you know something may be wrong and you may need to go to the dermatologist? It don't need to hurt. It needs to change. It don't have to turn gross. It don't have to hurt. It doesn't have to get like the pictures you see in your textbook. Trust me, I ain't have something like that on my arm. Okay, I had what looks like a little freckle, just like all these other little freckles I have on my arm. Okay. And I looked at it one day and I thought, that looks darker than I ever remembered it looking. The edges weren't irregular and all that good stuff. So I had that, and I had a little spot on my leg. And I was like, oh, well, I guess I'll just go to the dermatologist and let him look at it. And then my mom aggravated the hell out of me till I went. So I went to the dermatologist, right? Don't ever show your mom something unless you're ready to go to the doctor, because they're going to make you go, right? So I went, and he said, yeah, that is kind of dark. So he cut it off. Okay, just a little cut, didn't even have a scar. Cut that other thing off my leg too while he was at it. They like to cut it off when you go. You can go, they're going to cut something off, right? So I got a call a couple weeks later and said, oh, we want to let you know that spot we cut off your arm was a melanoma, and you need to come back in so we can remove some more tissue. So I didn't really know what that meant. I went back in. They numbed my entire arm, and then I watched, and they took a scalpel, and they started about right here, and they cut all the way around here and cut down in and removed an entire chunk of tissue out of my arm. And they said, okay, now we'll check this and see if it has any more melanoma. And if it doesn't, you're good. If it does, we're going to have to cut more. And now, I don't know if you can see it from the back, I still have a pretty good scar for it to have been just a little thing cut off my arm. But it healed, and now you can't hardly tell. And now when I get a nice pretty tan, you can see that big white streak. It's like my big sign. You shouldn't get a tan. See my big white streak, my big scar. But that's what they do. If the only thing we can do about a skin cancer is chop that bad skin off that is growing out of control and get rid of it. A melanoma is actually one of the most dangerous. And the only reason I knew something was wrong is because it was dark. So the reason I'm telling you this story is If you see anything that you think even remotely looks like it looks different than it used to, it's worth going, because most people think it needs to hurt. Or if you look at pictures in your textbook, you would think, oh my God, I can't believe anybody would have that on their body and not go to the doctor. It doesn't have to look like that. Okay? A lot of older men will get them on their head. Why? Bald, they lose their hair, and so it's exposed to the sun. I always tease my dad anytime we go to the beach or a big family vacation every year. I always come telling Dad, we need to put sunscreen on your head. No one's going to put sunscreen on his head. That's what daughters are for. All right. I'm through preaching for the day. Now, so what are we going to do with these appendages of the skin? What I want you to know is that they are all derivatives of the epidermis. What does that sentence mean? They come from the epidermis. So what type of tissue are they made of? Epithelial or connective? Epithelial. How can I remember that? Which tissue is more regenerative, epithelial or connective? Epithelial. Do my hair and fingernails grow? So they must be made of epithelial tissue, right? Okay. All right. So first we're going to look at our glands. Okay. So I told you there's two types of glands. Sweat glands, excuse me. There's eccrine sweat glands and apocrine sweat glands. Eccrine sweat glands are found lots of places, but in abundance they're found palms of your hand, soles of your feet, and on your forehead. They are 99% water. Does water stink? Not naturally, right? So do you think this type of sweat is going to smell bad? This is not stinky sweat. It is simply for the purpose of thermoregulation, cooling your body down. Okay? Now some people always argue with me and say, well, when so-and-so, when my husband's feet sweat, it stinks. Well, is that true? What stinks, his feet or his his fungus? His feet or his leather shoes? His shoes are what stinks. Whenever the leather that the shoe is made of stays moist, typically things like fungus and other things start growing, and that's the smell you get. But the actual sweat coming out of the foot itself doesn't stink. Okay? If we, don't I have a picture? Okay. Well, if we go back and look at that beginning picture, and we'll see them in labs, the eccrine sweat glands, they are little glands that sit down in the dermis, and they have a duct that comes up and dumps out on the top of the epidermis. Okay? The other one, the apocrine sweat glands, are only found in the axillary and anogenital regions. Okay? They produce the stinky stuff. Okay? And they are usually going to be connected to a hair follicle. Okay? So you can't ever have these on palms of the hand and soles of the feet. Now, I always have people argue with me, but the apocrine sweat glands do not start functioning until puberty. Okay? That's why if you have a little bitty 5-year-old, do they wear deodorant? Now, you're actually not supposed to put deodorant on them until about the time they hit puberty, because you can block some of the production of their natural sweat glands. You're not supposed to put deodorant on them until they actually start to need it. When you start smelling them, then, I mean, you don't let them be the stinky kid at school, but when you start smelling them, you need to start putting it on there. Now, I agree. And there are some kids their apocrine sweat glands start working younger than other kids. Yeah, I mean, we all remember that stinky kid in school when we were a little kid, right? And when we always picked on because he was stinky. It could have been a she, I guess. It was always a he in my classes, right? So, and here's the part y'all are going to laugh at, okay? Mixed into that stinky sweat is something that actually smells good, called a pheromone, okay? So if a man is sweating, a woman's not going to think he smells as bad as another guy thinks he smells. If a woman is sweating from these sweat glands, a guy is not going to think she smells as bad as another girl thinks she smells. Okay, and so see if any of you agree with me. I'm married. Okay, look, you already agree with me, right? I'm married, and I'll tell you, when my husband first starts to sweat, I'm not talking about when he's like drenched in sweat and all disgusting. When he first starts to sweat, it kind of smells good. Do any of you agree with that? Think about it. Some of y'all are like, but when a man, speaking as a woman, when a man first starts to sweat, there's something kind of nice about that. And then it starts to sting, and we're like, okay, get off. You're beyond the point of it smelled good, right? But right at first starts to smell good. And that's why, same goes for a man. Men usually think women in a gym are sexy. And I never understood that because when I'm in the gym, I'm pretty disgusting looking. But most guys will say there's something sexy about a woman that's just starting to sweat. She's working out a little bit. She's got a little glisten to her skin. She's sweating. And then eventually she'll start to smell bad, right? There's a point, okay? I think some of it, though, comes from the deodorants that we wear now. And especially with men. When men start to sweat, that's when you really smell their deodorant. And it always has a pretty good smell to it. You know what I see? So I'm glad y'all agree with me. Usually nobody in the class will agree with me, and I understand if you're saying that sweat smells good. But all right, so that's kind of the little sexual gland throwing in that little scent as well. And if you're in a committed relationship with somebody, they actually smell better than some other guy because there's a physical attraction between the two. Okay? So now that I've said that, let me switch gears completely and say apical sweat glands, some of them have modified into having very specific functions. And we're not going to talk about all of them, but I want to point one out because I think it's so funny. It's so far away from the normal function of an apical sweat gland. One modified one is a ceruminous gland. That is the gland in your ear that produces your earwax. So the same gland that produces something that makes women think a guy smells good at first makes that old cruddy stuff that we can't stand to see coming out of their ear. But it's still kind of the same type of gland. And even weirder, a mammary gland is an apical sweat gland. What does a mammary gland make? Milk, all right? They're in female breasts to produce breast milk, okay? Still just an apical sweat gland, but it's changed just enough. So instead of producing stinky sweat, it produces milk. It does stink. I agree with you. If you have never been around breast milk, it don't smell like milk, and it doesn't look like milk. No, it doesn't. I never tasted it, but I can say it can't taste as bad as the baby formula smells because, and that's all it is. It's mainly just it should be sweeter than milk because of the composition of it. It should be sweeter than regular milk, okay? It does make baby's poo smell better. Formula poo and food poo. Now, when they're on breast milk, though, they poo every 15 minutes, but it doesn't stink. I never forget, first got Kara home, you know, trying to breastfeed, trying to take care of her. Never changed the diaper. Know what I was doing. Okay, why was I going to change someone else's kid's diapers when I waited till I had my own? Right. My husband's a police officer, so he's gone. I'm there by myself with this kid. Didn't know what to do. She'd wake me up every 15 minutes. Hungry. I'd feed her, get her diaper changed, finally start getting her to go back to sleep, then all of a sudden she poop everywhere, every time. So, but we're going to talk more about breast milk and breastfeeding a little later. Very interesting. All right. I had something else I wanted to say, now I forgot. Anyway, the last type of gland we have is called a sebaceous gland. This is an oil gland. These are the ones that are attached to your hair follicles directly. They produce oil that runs onto your hair. This is something else that only becomes fully active at puberty. Any of you that have young children know. I can go a week without washing Kara's hair if I wanted to, and it still wouldn't look oily. Okay? I can't go a day without washing my hair, and it looks oily. Because once you hit puberty, you really start producing. It is different from person to person. I have a very good friend. She washes her hair once a week, and I'm so jealous because her hair always looks better than mine. And I wash my hair every morning, and by the end of the day, I feel like it looks like I have just rubbed oil on it. But if it makes you feel any better, those of you that have to wash your hair like every day because it's oily, your hair is healthier than the person that generally doesn't have to wash it because the more oil you produce, the healthier your hair is. What about your skin? Is it better for your skin to be oily? It really is. Most people think, no, oil causes acne. Nope, guess what causes acne? Bacteria causes acne. But as far as like just the little red pimples that have nothing to do with bacteria acne, just little, I can't think of a better word, but little, you know what I'm talking about, little small pimples. Someone with really dry skin is just as likely to have those as somebody with really oily skin. You don't want your skin to be too dry. It's very, very bad to take a bunch of baths and then lather up with Victoria's Secret pear glaze lotion. That's not natural oil on your skin. The natural oil is much, much better. And usually the lotions that don't smell quite as good are actually better for your skin than the ones that smell really, really good. Like cocoa butter and things like that. Natural cocoa butter, not the good smelling cocoa butter. Natural cocoa butter is better for your skin than some of the others. My husband hates it though. He says it smells like I've been at the beach all day. All right. Now, what time is it? 1:20. All right. So we'll pick back up here next time. Okay? That's kind of an abrupt stop, sorry.